Hi guys. So in this problem, we're going to find a derivative and we're going to practice simplifying. And so the simplifying part of it is the most challenging part. So we are going to find the derivative and simplify of f of x equals x squared times the square root of 1 minus x squared. Okay, this is a little bit ugly. We have two different things that are going on. We have a product rule and I know there's a product rule because I have a function times another function. So I could call this one function and I could call this my second function. But then in my second function, I have a chain rule. So it's kind of ugly. So what we need to do is we need to start with the product rule. And the product rule is take this and multiply it by the derivative of this, and then add it and go the opposite direction. So f prime of x is going to be x squared times the derivative of the square root of 1 minus x squared. So we have x squared times the derivative of 1 minus x squared plus the square root of 1 minus x squared times the derivative of x squared. So we have to do that business. We have to apply these operations and then simplify. So x squared, well, that's easy enough. That's going to be x squared times, I need to find the derivative of this. To find the derivative of this, I have to apply the chain rule. So let's take a little side adventure. Let's find the derivative of the square root of 1 minus x squared. Well, remember our outside function is the 1/2 power. So I'm going to multiply by a 1/2 power. I'm going to drop an exponent. 1/2 minus 1 is negative 1/2. Keep the inside the same, and then multiply by the derivative of the inside. The derivative of the inside is negative 2x. Whew, man, and this is just a part of taking the overall derivative. So I'm going to simplify this. 1/2 times negative 2x is just negative x, and a negative 1/2 in the exponent is going to make this drop down like this. So this is what this equals. This is the derivative right there. So the derivative of this is this. So I'm going to replace that part of this equation with negative x over the square root of 1 minus x squared. I'm going to add that to, well, I'm just going to leave that because remember the product rule is this times the derivative of this plus this times the derivative of that. So I'm going to leave this as 1 minus x squared. And then lucky for us, the derivative of x squared is pretty simple. It's just 2x. Okay, we've taken the derivative. That wasn't so bad. Now we need to simplify it. So let's write this a little bit prettier. X squared times negative x is negative x cubed. And that's all over the square root of 1 minus x squared. Plus, we're going to put the 2x in the front. So to simplify this, we are going to go back to pre-calculus. And in pre-calculus, even in algebra 2, we learned that to add fractions or add rational things, you have to have a common denominator. So the common denominator here would be this. So I'm going to multiply the top and the bottom of this term by the square root of 1 minus x squared. What happens then is this 1 minus x squared times the square root of 1 minus x squared, the square root cancels out. And so I have negative x cubed plus 2x times 1 minus x squared, because our square roots cancel out. And now that we have a common denominator, I can put everything over the square root of 1 minus x squared. We're almost done. We almost have this simplified. Let's go ahead and distribute that in. So we have negative x cubed plus 2x minus 2x cubed all over the square root of 1 minus x squared. I'm going to combine my like terms here. And we're going to get negative 3x cubed plus 2x all over the square root of 1 minus x squared. And that would be our simplified expression. So we had to recognize a couple of things here. We had to recognize that we were doing a product rule. And in order to do the product rule, we had to do the chain rule. And so we took we wrote this as u dv plus v du. Then off to the side, we took a little tangent here, and we found out what the derivative of this was using the chain rule. And then we just put everything into our equation. And then we used what we knew about pre-calculus and algebra to simplify.